Good afternoon. Good afternoon. Thank you. I'm Dinesh Manocha, faculty in computer science, along with my co-host, Professor Henry Fuchs, and the rest of the department. I want to welcome to you a very special series on lecture on computer graphics and virtual reality. Our speaker today is Richard Marks from Sony Entertainment. Richard has a very interesting and diverse background. As undergrad, he was at MIT studying avionics. Then he moved to the West Coast and got his PhD at Stanford working on underwater robotics. So he'll tell us about connection between avionics and underwater robotics. After that, he joined a startup doing computer vision, which got acquired by Autodesk. And he has been at Sony since almost 2099, right? 16 years working with PlayStation. Now, how many of you remember that was the time when PS2 came out?
Right.
And Richard has been involved with lots. If you've been playing with the PlayStation and you do a lot of cool stuff, Richard deserves a lot of credit for that. And this includes things like the development of PlayStation Move, design of a PlayStation 4 camera and dual stock. And more recently, for the last 12, 13 months, since last GDC, Richard has been a lot in the press as being one of the main persons behind the Morpheus, which is somewhere sitting right here. So without further ado, let's welcome Richard to UNC Chapel Hill and look forward to a great talk.
Thanks. Thank you. It's on. Yep. Thank you. This is my first time to this university, and it's great to be here. It's a very nice campus. I wish I could stay here longer. I have to leave tomorrow. So I'm going to talk about a few different things, a little bit go back into the past and bring it all the way to the current day. So if you're chomping at the bit to hear about VR, just hold on and I'll get there eventually, I promise. So real quick, a little bit more about my background. And you don't need it. Okay, that's fine. My parents had a video game store when I was in high school. I was the chief demo officer. I would open every game, play it, learn what it was, and then be able to talk about it. And then the video game market crashed, and then we got out of that business. And then I went to school and studied avionics, as you already mentioned. And then I worked at a startup for a while. Then I saw the PlayStation 2 unveiled, and I've been at PlayStation R&D ever since. I've gotten to work on a lot of different things, physical simulation, computer vision, man-machine interface. But really, I saw the PlayStation 2 when it was unveiled, and it's the power of the hardware I realized would be really good as a computation platform and doing a lot of things that probably video game developers wouldn't otherwise do, like computer vision, for example. And so that's why I joined PlayStation. Now I have two roles at PlayStation, as Dinesh mentioned. I actually do a lot of the technical PR for the company. I explain other people's work sometimes, and including Morpheus and things like the PlayStation 4 when it was launched. I helped with that. That isn't why I'm here today. I just want you, even though I'm wearing the same shirt I'm wearing in that picture right there. Today I'm in the second role, which is more about focused on technology research and breaking new ground. So what I'm saying here today doesn't represent something that's going to come out next year or something. It's things we're looking at. They're very speculative. So I've done a lot of really cool things and had a lot of fun time. Let's see. If I go back here, the person on the left here, up here doing that demonstration with me, that's Kaz Hirai. He's the CEO of Sony. And maybe you guys know Jimmy Fallon down there. We got to show things on there. So that's a really fun part of my job. But also when we do the technology stuff, we get a lot of fun things too. Over here, we were doing some tracking of colored objects work. You see, that's me holding that, and that's Jet Li over there, and he tried our sword tracking demonstration. He is not the guy you want to try a sword tracking demonstration with, because our system was unable to track how fast he could move a sword. It was not up to his level. But actually, we were running at 30 hertz. The cameras were 30 hertz then, and we switched to 60 hertz after that. So as part of this kind of research and technology, what I do is I manage or direct the PlayStation Magic Lab. And it's a group of guys. Basically, we take technology and we create new experiences with technology. Sometimes it's internal Sony tech, and sometimes it's not our own tech. But it's really about rapid prototyping of these experiences and what you could do with this if you had it. And maybe the other side is we sometimes Wizard of Oz things, and if we don't quite have the technology, would it be worth investing in the technology in order to get it? Because the experience would be so amazing. So sometimes we get very expensive technology and make an experience for it, all kinds of different things. And we work a lot with other groups within Sony to do that. And so our goal, PlayStation, if you work at the PlayStation R&D, basically, people have a vision of what that might be like. Our vision is maybe more like this, kind of like Iron Man's lab, right? We have access to a lot of cool tech. We try to build things. OK, so on to the main part of the talk. Basically, when I started, the graphics technology boom was occurring, and video games were really kind of taking off, becoming more mainstream than they'd ever been. Some of the big areas that video games incorporate technology-wise, these are just 4 main ones. There's others, of course. Network probably deserves to be on here, too. But I don't do much with the network, so I didn't put it on here. So there's graphics is the biggest one. And graphics was just going so fast when I started. And the processing power is just getting so much better. And display. And then input is my area, and I'll talk about this. But one of the great things about video games is we can try out the latest and greatest technologies. And if we do anything wrong or make any mistakes or make stuff that doesn't work perfect, it's not as dangerous, or it's not like these levels of engineering that have to have 4 nines of safety the same way, because no plane crashes if the video game crashes. So we try to push the limits. I mean, we clock our things, and we do use every ounce of the CPU that we can. And that's just kind of a great thing about working in video games, is we have the ability to do that. And same thing with the other kinds of tech that we use. So with graphics, I'm not going to spend much time on this. This is not really my main area, but during the time I've been at, working in PlayStation and in this area, just the graphics has come so far. And I used to use this example of this Kara demo. If you've never seen it, it's a very impressive graphics demo that runs in real time on a PS3. But now we're past this, and we have PlayStation 4, and we have this, if you've ever seen the trailer for Uncharted 4, like you can actually see the reflection of the room in his eye. That's the rendering level that they're going to for in real-time rendering. They're really pushing that far. For processing, there's been a huge ramp in the PC kind of price performance, and the console market has benefited from that as well. There's also now cloud computing is this ability to kind of tap into infinite resource. Now, from a business standpoint, it doesn't mean you can make money if you have infinite computation needs for your application, but it's there and it's accessible. So that's also there. And then display technology, again, you probably have seen you probably don't remember when there weren't flat screens, but there's been a huge ramp in this, especially in the mobile displays. And kind of, there's now portable 3D, like the 3DS is an example, and then head-mount displays. Again, this is not really my area, but all this stuff was happening, and has been happening in the game industry. But the area I focused on more during my career is input, and the kind of traditional inputs. But then there's been a lot of work in this area recently too, during the time I've been at PlayStation. And it's not just us that's doing this work. It's all the different companies that have been pushing it. Touch was a huge thing that came about. And then also, the Wii and the Kinect were huge impacts to the gaming industry. So for me, this is why I actually care about video games, input, and the interactivity. To me, that's the differentiator between a game and something like a movie or some other kind of media. I hate games where you just basically are pressing X and then you hear another story and press. I mean, I don't hate them. It's just that isn't a game. It's like watching a movie, but you press X sometimes. If it's a good movie, it's still a good movie, but it's not really why I work in the game industry. So I think some of the things that matter a lot to people who play games is having this kind of direct cause and effect. What I do matters. When I do something, and there's this great kind of feeling of input amplification where maybe I just press a button and this huge thing happens on the screen. That's a great feeling. Feels like you are really causing a giant change to happen in the world you're in. Also, it gives this kind of ability to transfer your identity into some other experience. Like when you watch a movie, you don't usually say, when like Luke Skywalker dies, you don't say, I died or something like that. You have never gotten that close. Whereas when you play a game, you often have that feeling that, even if it's not a first-person shooter, even if you're playing, Mario, when Mario dies, you still might say, "I died," because you feel like you're directly controlling him. So, and that the interface is really what connects the player to the game. So it's a huge, important part of every game. And so that's why I think the fact that when I joined, the kind of state-of-the-art pretty much was like a gamepad, which you can do a lot with. Have these awesome button combinations to play something like this fighting game. But nowadays, we have so much more input than that. We have cameras, microphones, touch, gamepad, and all this data we can take into account what the player would like to have happen and generate something really awesome on the other side. Anything. But. So the different input modalities, I've already mentioned touch. Inertial systems came way down in price. There's kind of this interface revolution as cameras and inertial systems all dropped in price and gave us the ability to do a lot of new things. I really thought RFID would somehow get used more in gaming than it has, but it never quite did. Voice, has always been sitting there and never quite hit its full potential yet. But for me, I chose to focus on video mostly, partly because I had a computer vision background. So also, though, another reason to focus on video is it's very familiar to people. They understand video pretty well. I've done stuff with ultrasonics, and people don't quite get it when it doesn't work because there's no real understanding of why the multipath in the room is the way it is or something. So it's familiar. It's pretty fast. It's extremely kind of spatial and physical. And it's personal because what you're doing, you see yourself if you display the video. You can use the video for other things like streaming or recording something. So it has other reasons that you can justify the cost of the sensor that you have there. And so I think video has a lot to offer, and that's really why we've used it for so many different things throughout my career. Some of the different research we've done, maybe I'll just start one of these videos to give you an idea. Well, before I start, we did some early work where we were trying to do some structure from motion stuff on the face, and actually there was a bug, and the little markers we were drawing actually looked like bugs. And so instead of doing structure for motion, they just became motion only. And so then they just moved around when you move them, like optical flow kind of based. And then all these bugs were moving around, and that turned out to be better than what we were trying to do before that. So kind of a fortunate mistake. In the middle, right after, we had two interns who were working on kind of an interactive music interface, and then they saw a Minority Report, and they came back and said, "We want to make the Minority Report interface." So they mocked up this kind of retroreflective material on the hand and did some gesture input through that. And we have a camera with a light shining out from it. Actually, the EyeToy has a LED that was designed for retroreflective things. It just never got used in a product. Let me start this one, though. I already mentioned the sword tracking. That is not Jet Li. That's the researcher that worked on it. This is, just to give you a feeling, though, he's 3 years old here. Now he's 17 and 6'6" tall. So this has been a long career for me. Yahoo! So what we're doing here is we're tracking the color of the sphere. And that's really basically giving us a 3D position of the sphere based on its radius and its centroid. And so we can render an object. We actually are rendering a sphere into the Z buffer, only the Z buffer. So that's why it occludes the feet of the little character there. So it looks like he's kind of behind the sphere there. And the exciting thing we thought about this is here's a 3-year-old, and he's playing with an object in 3D, and he understands how to move it around and do stuff. Trying to make any kind of thing that could do that with a joystick would be really hard in 3D. And so this was not scripted. It was like the night before SIGGRAPH Emerging Technologies video was due, so we're like recording. And so that's the setup, just a camera in front of the television. Like this is now kind of common where you have a camera with a game system, like Kinect or EyeToy. But it's just a foam ball stuck on a pencil. And so here's another demonstration. In our lab is Craig Reynolds, who worked on flocking behavior. And so we took some of his, easy to do flocking stuff and made butterflies. And so the butterflies kind of swarm around and they try. He was very proud of himself once he discovered that he could hide the ball. And I already mentioned the Z-buffer rendering trick. So if you watch, there's a mistake. I already used the bug joke, so where the Z-buffer, where the rendering messes up. Right. No, maybe not. Okay. And so as like the spatial tracking is really what excited me from a technical standpoint, but actually just motion-based input is pretty fun for kids. And it turns out that just motion-based input is a little bit easier to use for some kinds of gameplay things. So just generating fire like this, and so it's also a lesson we should have learned more later, I'll mention. So this is just using the same input, just a motion buffer, basically, motion detection. And then I told him to sit really still. And amazingly, as a 3-year-old, he's very good at sitting still. Until he's not. All right. OK. And then this, again, same kind of thing where we're tracking colored objects. Here's the EyeToy camera. This is one on the PlayStation 3, when we first got the PlayStation 3 hardware, actually. But it's before the PlayStation 3 was launched or even revealed. And now these objects are not spheres. They're kind of have a aspect ratio to them, so we can get the orientation in 2D of them easily. And so Eric Larson, here, he was working on water simulation at the time, so we combined his water simulation with this interface. And it's a really great feeling to pour water back and forth like that. It's really feels. Actually, anytime you mix these kind of interfaces with physics, you get a really great effect. And I mean, just playing and trying to see if the water, oh, yep, it does behave the way it should when it hits itself. All right, and you can refill it and stuff. And then going back to the colored objects, here's me again now with the spheres again. And Vangelis Kokovis, he was working on cloth simulation, so let's hook that up to the tracking system. So here you see the cloth, and it falls out of the sky onto the spheres. But we don't have to render the spheres to the display. We can, if we turn off the sphere rendering and then still run it, it looks pretty cool that the cloth just falls onto the video and does the right thing. All right. So that's some kind of things we did. So EyeToy was the first product we made that was intended to let us do some of this stuff. It was a special purpose camera, but it's pretty much a webcam. It was just really well matched to the PlayStation 2. The PlayStation 2 had a DVD capability, so this thing could compress MPEG iframes. So the PlayStation 2 could use hardware decompression, so it was basically free to decompress the video. And we did 60 frames per second, which at the time, no one was doing that really. And so the video felt very fluid. Even though it wasn't that high res, it just felt very fluid. And it was good for doing tracking kinds of stuff. And so kind of did lots of products that used EyeToy. It was a lot big. It sold like over 15 million units or something. But it was much bigger in Europe. It was all the content mostly was developed in Europe, and they marketed it more heavily there. Then we switched to doing depth camera research. And so we worked on something. There's lots of different kinds of depth camera. There's time-of-flight-based systems. There's triangulation-based systems, like stereo. And then there's like active illumination systems with kind of a triangulation, like First Connect used. So we had all those different systems in our lab. And we had my focus at the time was more on augmented reality. So here we're using just the depth camera. And basically, you find the torso is the biggest blob in the scene, and then anything that's 2 feet out in front of it must be a hand, is the assumption. So it's a very simple concept, but it just like, it's not tracking your hand, right? But when you hold out your hand, then it starts to track. And what that does is it lets you address the system. It's a really big problem vision systems have a lot, is that they're always on, it feels like. So this, like especially motion systems, it's really hard. There's a great joke inside of the Minority Report movie where he goes to do something and he goes to shake somebody's hand and a window flies across his computer desktop because it's tracking his hand while he's doing it. Kind of inside joke. But so here we're just showing the kinds of things you could use a depth camera for if you use it as for tracking. And so it's got a really simple gesture recognition system. And so we showed this at SIGGRAPH. There was actually 2 systems networked against each other. And so you could cast spells, and they happened to the other person, and then he could cast a spell. And it was supposed to be like there was a counter spell for every spell, and you'd have this battle. But we didn't finish the counter spells, so it was really just an attack. You both attacked each other. And here I'm hiding underneath the camera because when I went down there, I took a picture while I was off screen, which now allows me to do this spell, which is so it's a trick where you just alpha the live video with a static image behind. But it looks like you're invisible. Yeah, so what happens a lot when you'd have to do these kind of demos is I don't have access to art. So that first hurricane spell, an artist helped me with, but then I had to do everything where there was no art anymore. So it starts to look a little more programmer art-like, you know. Yeah. And so the other great thing is, again, since he's in the background with a depth camera, he's not affecting the system at all. So he could be doing whatever he wants, and it doesn't affect the system. So we thought depth cameras had a lot of promise. We did not end up productizing a depth camera. Here's another demonstration by one of my colleagues. So this is around the time he was interested in using it for real-time motion capture. So he had kind of a simple hand, like arm finder and head finder. You could do these things where you physically interacted and kind of puppeted a skeleton. And again, this is like, I think, SIGGRAPH 2003 maybe? Or something like that. So pretty far before we're going to, and the Matrix. Whenever the Matrix came out, that's when this demo was made. And yeah, so the Kinect, basically went that direction. And they didn't do so much with augmented reality, but they did do the tracking of the body and things like that. As a company, we chose to instead focus on something that was lower cost and gave us a different set of capabilities. So we came out with basically a better EyeToy. So this is called the PlayStation Eye, higher res, uncompressed video, so there were no compression artifacts this time. And had a microphone array across the top, which never got used as much as we thought it would. It had 2 different fields of view, so you could have kind of narrow headshot or a very wide field of view for like a full body kind of thing. And that gave us some other capabilities. There's a game called Eye of Judgment that came out. And then there's some other tracking in Europe. This is very cool stuff that just, if you have pretty good video input, he just did feature tracking. And this is running on I guess PS3. And you could, just based on the features, you could kind of collectively move around something like an input, like a control, like a dial, like this. And so, yeah, just showing and you could do it with the scale of it and stuff, just by tracking a lot of little features. And so in our lab, what we started to do right about this time is we thought, well, what if we had combined video with other input modalities? So one of the big things we lose with video is there's no button. So you lose that very nice discrete input that it means I would like something to happen right now. Trying to use gestures for that, that sometimes doesn't work nearly as well as you would like. And buttons are really hard to replace. Also, most of the video stuff we didn't get full 6 degree of freedom orientation. So we made this thing. This is, again, the foam ball stuck onto the end of a DualShock 3 that a Dremel had been taken to it so that you could hold it in one hand. And so it's missing the parts you normally hold, and you hold it vertically. So now you can, here's thumb buttons for you to use, and it also had the sensors from the DualShock 3 in it, and then the ball could be tracked. And that is obviously a research prototype, not a final product. That turned into PlayStation Move, which is everyone called it a motion controller at the time. That's not really the way we thought of it. We thought of it as a spatial controller. So you really get 6 degrees of freedom, and it knows, the full pose of your hand, and you get these buttons that you can do things with. And it's very low latency, and we thought it would enable a whole bunch of new kinds of spatial entertainment experiences. I'm not going to go into too much detail, but it had a lot of cool hardware inside. It has a rumble, and it has gyro accelerometer for the inertials, and basically there's an analog trigger button, and it has this kind of like one-handed handle design. And the handle design, I think, the ergonomics are underappreciated. Actually, the fact that it tapers means that no matter the size of your hand, it kind of feels like you can find a place where it feels good in your hand. There's a lot of products that do that, actually, so that you can always feel like no matter what your hand size is, it feels good. And I already mentioned this, the PlayStation Eye is used to track the sphere. Actually, the system can calibrate so that it flashes the sphere, and then it figures out what colors are in the room, and then it picks a color for the sphere that's not in the room, so it always will track even if there's a bright colored light in the background or something like that. And then there's a data fusion step where it's taking the inertial sensors. The accelerometer gives you some information about position change, and it fuses that data together to get a really high tracking precision, and also it does some prediction so that you get a perceived lower latency. You can't predict too much because hands can move pretty fast, so if you predict too much, it starts to feel kind of springy, and it kind of doesn't work as well, but you can predict a little bit. And then just to show how this works, the fact that it's a sphere in this case was really important because we could get an estimate of its radius, which gives us an estimate of its distance away from the camera, because we only had a monocular camera for this step. So it gave us this ability, and we had a really precise approach to doing this. Let me just run this video. Just to give you a feeling of the latency. I mean, this is an augmented reality demo, basically. We're showing the video, and then we're just rendering the intensity distribution of the sphere next to it, those red and blue lines. So it just looks like it's rigidly attached to the sphere, but of course it's not. We're rendering that in. So that's just an idea of how it works. So these are the kinds of experiences that were generated. Probably one of the best ones was the one that came with the Move. It's called Sports Champions. There was one where you had a sword and a shield, and there was a ping pong game. It was also used for Wonderbook, and then but it turned out people found it a little bit confusing. Well, Wonderbook is hard because you're looking effectively into a mirror, and you're trying to do something on a different plane, and it's confusing to do the mapping in a mirror for a lot of people, especially kids had some problem with that. Other things, even when you're doing something like that bottom demo where I'm just stacking blocks, trying to stack something in 3D using a 2D display but a 3D input, you have to be kind of expert in order to do that. And a lot of people just found it confusing. And they mostly did 2D things all the time. And they never used the 3D-ness of it at all because they have a 2D display. There was a gun peripheral, which worked out pretty well, actually. Once you kind of do a gun, then you can point it. And it's pretty much a pointer at that point. And that worked OK. But it kind of lost the whole benefit of the spatial tracking. So could have done that a different way. I mean, people had light guns for a long time. So yeah, actually I think the Move was a little bit ahead of its time, really. I think it would have been really ideal for VR, but we didn't have a VR headset at the time. So people actually, when the Move came out, all the people internally in Sony, they took the Move and they just hooked it on their head, and then they got some head mount displays that existed, and they made a kind of crude VR system out of it. And that worked pretty good because the tracking was good for that. But we didn't really think that putting a Move on your head would work out long term. Maybe like a mining game or something where you're diving in, so it's lit up. But yeah, so before I go on to VR, we got to catch up a little bit. Next stages of this stuff was PlayStation 4, and the neat thing about PlayStation 4 was the camera, the controller, and the console were all designed in combination by this cross-territory team, which I got to be part of. So they all were designed to work together well. which is great. Down on the left, you can see the kind of crosshairs that are on the controller, because the controller can be tracked by the camera. And actually, a really great demonstration of this capability and all the capabilities are the Playroom, which is pre-installed on the PlayStation 4. So everyone gets it. All they need to get is the camera. They have to buy separate. And then they can do all these things with the controller and the tracking. And it's an augmented reality experience. And you can flick these little robots out into the actually, I'll just show it. I don't have the video of the Jimmy Fallon show because you could watch that online. But here's a video that just... So this was the video we sent to the Jimmy Fallon show to get them interested in showing this stuff on. And it happened to be, when they asked for the video, they said, oh, we need it today. And it happened to be Halloween that day. So I was dressed as James Bond for Halloween. So I don't normally dress in a bow tie for work. But that's why it's like that. So this is just showing some of the tracking capabilities of the controller. And maybe I'll skip ahead to... Yeah, so here's like you can kind of rub the thing and it makes this appear. And then if you push the touchpad, oh yeah, it scans your face. There's a face detector, and then it has a kind of pose of your head. I don't want to miss the step where it tells you yeah, it uses motion detection too, so you can kind of interact with things. Yeah, so it's telling me to push the button. That pops up like a kind of virtual menu that floats above the controller. And you can use the touchpad of the controller to rotate it. I'm going to skip ahead here. So basically what's happening here is the robot is filling my controller up with a bunch of little robots. And then I can flick them out onto the floor. So this is what you see on your television. This is just the raw output of the television screen that is being shown here. Anyway, if you haven't played the Playroom, it's worth trying. And anyone who has a PlayStation camera and a PlayStation 4 can try it. We'll move on here. So the PlayStation camera, it's basically two RGB cameras that we can do stereo with. And it's, again, higher res, uncompressed, wider field of view than we had before. It's basically a really good, high-quality webcam. And also, it has a built-in accelerometer, so we know the tilt of it. So we can know its orientation relative to the world, which is important, because otherwise we have to calibrate that out. And then the main thing that you would think of with a stereo camera is you can use it for getting a depth map of the world, which we can do to some degree, like you can do with stereo. That requires good lighting. There's no active lighting solution to it, so it requires lighting in the room. So really what the camera is good for, though, is it's good for tracking the 3D position of colored LEDs, like the one on the controller, like the one on the PlayStation Move, or like the many that are on the on Morpheus. But I'm still not quite to Morpheus. There's one more thing that my lab's been working on, unrelated to VR, pretty much, which is direction of gaze. And this is really cool work. It's a really cool input that I just wanted to make sure I talked about. And we showed it at GDC last year. Knowing where you're looking is a huge piece of information. It knows what it really is related to your intent. It's not great for causing an action to occur. It's more about what action I would like to have happen. So a button press is still a great way to make an action occur, but which action it should be, your eyes can really tell a lot about. So it works really well with something like PlayStation Move as an input device, where you use the buttons to select, and then once you've selected, now you have a spatial control over the thing you've selected through the PlayStation Move. It's really intuitive. It's kind of like touch. Like having touch on a tablet is a little bit like having gaze with a television set. And I think our interest in it was potentially using it for something like a 10-foot UI for a television set. That was one of the ideas. But right now, the technology doesn't work very well at 10 feet away. Another thing you can do with it is give you this kind of magic feeling of telekinesis or the force. You can pick things up with your mind, kind of, because it knows what you were choosing because you were looking at it. And one of the great uses of it is for artificial game characters, because they know what you're looking at the time. They know what you're maybe thinking about. So we have this demo where there's like a shopkeeper, and you look at him and he walks over, and he's got 3 things for sale. And if you look at one of the things, he goes, oh, are you interested in that thing? It's for sale right now. And then he switches to something else if you look at something else. So it feels like he knows what you're interested in. You haven't even done anything but look at what's on the screen. It just makes everybody, all the artificial characters, feel more intelligent. And I think, I'm not going to talk about it today because it hasn't been talked about by my colleague, Eric Larson, who's the one who's working on it. But I think it has a lot of promise for VR, and there's several companies looking into this already that have talked about it. So I think it will be a really great thing in the future. So finally, get to Project Morpheus. And this is the new headset. And the big thing about virtual reality, I'm not going to be able to spend all the time I would take to motivate virtual reality, because probably everyone here would already agree that they're interested in it. There's presence is the buzzword that everyone's been using with virtual reality. And I've defined some different levels of presence that I feel. This is not a common agreement kind of breakdown, but basically if you put something in front of your eyes and it looks believable, that's kind of one level. If you put it in front of your eyes and then you can move your head around and it still looks believable, that's kind of the next level. And that's the first 2 levels here. Then there's other expectations you start to have after that, which is that I shouldn't look down and see my hands or my body. And then otherwise I'm not really there, because I look down and I'm not there, then I won't believe I'm there. And then also if I do something, I expect the environment or the scene will change and behave in a way that's, makes sense. So the environmental response. So it's these last 2 that I think are really key to gaming. The first 2, if you just want to watch some kind of virtual scene play out, you can have a really great feeling of presence as if you're kind of just standing there floating. But once you want to actually interact with the world, that's when it becomes a game again, that whole thing about whether games are really when you have interactivity. So that's where I think we as a company in the game industry need to contribute more than the rest of the world maybe to this one area of VR. Lots of things happening in this area as input for VR. This is, again, just a kind of arbitrary, for my own sake, breakdown of the way to think about these different interfaces. Joysticks and mouse and keyboard are very abstracted. Then you have the other end of the spectrum where you actually have to physically walk in order to move around the virtual world or something. And somewhere in between is this idea of spatialized controllers. And we already have a spatialized controller. We have the PlayStation Move. And the DualShock 4 is also spatialized to a certain extent. So this, I think, a lot is happening in this space right now. There's no great solution. It's almost impossible to think about a single answer that would cover everything you'd ever want to do in VR. But I think spatialized controllers are a great place to start. They allow kind of this direct physical interaction. They actually give you really consistent proprioceptive cues. You can't necessarily see your hand perfectly, and I'll talk about hands in a second, but you can see something that moves exactly in the way your hands are moving. And that really grounds you. Somehow when you see that something doing what it's supposed to be doing, it makes the whole world feel more solid and real, and you believe that it's there. I don't have any concrete data to back that up, but I have lots of anecdotal data. You can use it for a lot of different things, which I'll talk about. And there's several examples. I already mentioned R2 and the STEM system. And actually, the Hydra system is an old system, the Razer Hydra. And those, they were ahead of their time as well. They came out before Oculus came out. And now that Oculus is out, everyone wants Razer Hydras, even though they stopped making them. So now the only way to get them is on eBay, and they're really expensive. So I know that there's something there to this spatialized controller, because a lot of people want them right now. So the things we've tried to do with spatial controllers, the obvious one is manipulation, reaching out and grabbing things. We've shown the castle demo at lots of events where you have a sword in one hand, and you can have a crossbow, and you can have a flail that you can swing around. And you can actually see the gauntlets of your hand. And when you squeeze the analog trigger of the move, you actually see the gauntlet fingers moving the right amount to match your trigger press. It gives a really good feeling of having hands in the world, even though it's not actually your hands, it's these gauntlets. We've also done other things with with JPL, where we had a robot where you could reach into the world and manipulate the robot legs and move the robot around the world. And then recently at GDC, just 2 weeks ago, a demo called London Heist was shown where you're standing in front of a desk and they don't tell you anything, but you see drawers in front of you and you have hands that are rendered, and you can just reach, grab, open the drawers. You find a gun clip, so that encourages you to look for a gun. You find the gun and you can just put the gun clip into the gun, and all this stuff is very intuitive and natural. We didn't actually have to explain it to anybody, and then people start attacking you. So other things you can do with these spatial controllers is actually you can use them for navigation and locomotion. So one of the great things, I didn't show it in here, this image. Actually, we had a demonstration back in the PS3 days with Move where you were supposed to be like a chameleon and there was a branch. And the way you moved around the world is you saw your hands on the TV, and you could grab the branch and pull it towards you, and then you could grab the other part of the branch, and you could basically move yourself through the world on the branch. Well, the same idea can be used in VR, where you just basically you grab the world and move it wherever you want. And even though you can grab the world and move it in full 6 degrees of freedom, and it's moving all around you, people don't tend to get sick because it's their own arm motion that is causing the world to move like this. So your brain expects everything to behave kind of the way it behaves. Even though you can't actually move the world around this way, somehow the connection of this 6 degrees of freedom thing happening around you tends to not make people as sick as much. So you can just grab the world and just move through the world, pulling it towards you like this. Or you could rotate it 90 degrees easily. You feel very godlike when you can do this, just move around. Another thing you can do with these spatial controllers is you can grab 2 points in the world and then scale the whole world and make it bigger or smaller. And that also is a very cool feeling to be able to do that. And then the last thing you could do that we've tried with this kind of approach is you could just point at somewhere in the world and then teleport to that spot. If you try to fly to that spot, some people still don't like that feeling. But teleportation does not tend to make people sick. It makes them confused and they don't know where they are suddenly, but that doesn't make you sick. So it's a trade-off of whether, I can't teleport in the real world, so I don't know what to expect, so I don't have any feeling of sickness. But I think that once people get used to being able to be anywhere they want instantaneously, that's going to be a really cool interface. Right now, I think it confuses people a little bit, but I don't think it'll be like that forever. Probably, if you're in the VR community, you might have heard the world in miniature approach to navigation or locomotion. And this was done in 1995, University of Virginia. And what you see here is a small version of this room rendered here that you can hold in your hand, or maybe it could be static. And then you can kind of use a spatial controller to pick where you'd want to go to in the room, or maybe drag a path. You can use it in a lot of different ways, but basically it's a small version of the real big room, so you can get to somewhere very quickly. One of my colleagues was at a VR hackathon, and we brought PlayStation Move and Morpheus there for this overnight coding session. So he made this thing, they call it the zombie demo. And basically, I'm sorry you can't see it very well, and it's hard to see because I'm showing the screen output from what you'd see from the distortion. But basically, this is a small version of a room. The room was actually the room we were in for the hackathon that was scanned by a Matterport scanner. So we had this scan that you were standing in VR. And then in your hand was a small version of that scan. And then in your other hand was this tiny little hammer, very tiny little hammer. And zombies start to attack you. And this tiny little hammer can't do anything against the zombies in the real world. But in the miniature world, the zombies are really miniature, and you can hit the zombies with the hammer. And when you do that, in the real world, suddenly a giant hammer comes down and smashes the zombie. So it's this kind of Inception moment where, what we wondered is if you could see the little thing in that guy who you are inside the small world, was he also holding a small room? No. Anyways, it's just using the same ideas as this world in miniature for this kind of really fun gameplay to just basically you feel very powerful because you just have to do this much motion and you can kill the zombies all around you. But it is scary because they're attacking in the world. One other great thing about these spatial controllers is they give this kind of social feedback. If you're in VR with somebody else in a space, seeing their head motion is great, but seeing their hand motion is even more powerful. You can actually tell a lot of times who the person is just from the motion, no matter what you're rendering. So using it as a we had this demonstration on The Tonight Show, which this is like Jimmy Fallon and Channing Tatum. And it was a really cool demo, but they didn't really understand what they were doing very well. So they just started flailing around and fighting each other and stuff. But what really you could do is he could see him, and he could see him, and you could see their hands move. And he had a crossbow, and he had a sword, and he could actually shoot. They were both supposed to shoot this practice dummy, but they end up just attacking each other because that tends to be what everyone does. This demo, same NASA demo I mentioned before, where you can manipulate these this robot. It draws these kind of laser lines out of your controllers where you're going to manipulate something, and everyone just immediately turns the other person in VR and aims a laser into their eyes. It's like everyone does that every time because somehow just seeing the other person there with you makes you want to interact with them so badly. So having hands for that is great too. So we had an intern, and he did some great work in trying to understand what real hand tracking would give you. So there's a lot of different ways you could do hand tracking. A lot of different companies are looking at it. He made this kind of prototype where he just bolted something onto a Morpheus. And then one of the great things is seeing your own hands in VR gives you this really strong feeling of being grounded into the space. Really becomes believable. A lot of the systems right now have too much latency, and they are not necessarily reliable enough. So that doesn't feel great. But actually, another thing that matters a lot is how you render the hands. If you try to render the hands and they are not very well rendered, but they're human-like, and they look kind of like corpse hands, that is not a good feeling. But if you render kind of non-photorealistic hands, it's that seems to be much more okay with people. So being able to talk in VR with your hands is also a really powerful thing, probably even better for the social interaction than the spatial controllers. And he also used this, he did some work with gesture detection, being able to reach out into the world and pinch something with their hands. And then he used it as kind of this Pong paddle controller. So, I mean, I think this is also a really interesting path. We don't have as much experience with it as a company as we do with the controller approach. But I think it's still worth looking into. So we did kind of a pros of each system. I think the controller stuff is still more robust, still lower latency, still easier to do. Buttons are still really good to have, and when you don't have a controller, then you have no buttons again, and so you're without buttons. So having a controller feels much better for things like weapons and tools. But when you want something more freeform, you want to just kind of brush something out of the way, or you want to be more expressive in what you're saying, then the hand tracking is better. And also it feels less encumbering to have a free hand. I could see a combination perhaps where I have one controller in one hand and a free hand in the other. There aren't really systems that can do everything yet, but someday, probably in the future, there will be systems that could do all of these things. Yeah. So some other future areas we've been interested in looking in, and I've seen stuff other people have done in already. Being able to see your body in VR, we haven't really done anything with that other than with a static kind of body, which is just underneath the head. There are people that have done things like basically hooking a Kinect system up and then getting a body avatar. Some cool stuff with multiple Kinects. We have a camera that has a stereo map that we could potentially do something with. Although the way we run the camera, we set it at a low exposure so that we can basically track the LEDs more reliably, and we have a lower latency because of the low exposure. So I'm not sure that it's an ideal setup for us right now, but the actual system could potentially be used for both. Then voice input, there is a microphone built into the Morpheus, so you could, and I think a lot of people have thought about this. Having spatialized 3D audio is really important for VR in a lot of things, and having voices come out of the right spot when you're talking to somebody is huge. One of the most powerful VR experiences I've ever had was a virtual character came up behind me and just leaned in and whispered, and it was somebody I was voice chatting with, and they sounded like they were in my personal space, and that's very powerful because they felt like they were right over my shoulder when they were talking. So, and then also, combining all these other kinds of spatial things with voice command potential, I think could be good. And then we've looked a little bit at haptics. I don't know, maybe some of you people have heard of this. This picture on the right is from Tactical Haptics. It's called the reactive grip. And basically, it slides in your hand and pushes on your skin to make you feel like something potentially has weight or has a kick to it. It's different than rumble significantly, and I think for VR it has some really great potential. There are more advanced rumble techniques, I think, too, that are potentially good for VR. And actually what we found is just a little bit of haptics in VR goes a long way. It's just having a little cue. And really when you combine it with a spatial controller where you reach out and something just goes tick in your hand, like you feel it when you get to a spot, that's a really powerful feeling, because basically when you have this kind of translational movement or rotational movement and you get to a spot and you feel something happen, again, it makes everything just seem more real, like it's really there. So, concluding thoughts real quickly. I think interaction is the key to gaming, and I think it's key for VR game experiences and a lot of different VR experiences. There's still tons of work to do in this area. I think I have a long time ahead of me in this industry if I want to keep working on interaction. I think spatial input is, you have to have some form of that if you want to have a good VR controller. It's important not just to be able to interact with the virtual world, but I think for VR to really get big, you have to, it'll really have to be that you can be with other people in VR. So I think that's key. Improving interaction is really what's going to have to happen for VR to become bigger. And I think it'll give these more compelling experiences to people if they can interact in a better way. And I want to tell you, this talk was very research focused, and I'm happy to answer any questions about the talk. And I will be happy to answer more questions about our product. I didn't talk about it very much because I didn't want to make it like a kind of a sales pitch too much. But thank you very much for the time, you guys. Let me talk to you. And I'm happy to field any kind of question about any of this area that I can, if I can. Let's see if I have any more to show.
You want to introduce yourself?
Hi.
Oh, hi.
I'm Sharif. So all this awesome stuff, how do you filter that towards what goes into a product? Like, what relationship does it have to Sony, and what's the internal pull of it?
That's a really good question, and it's kind of $1 million question, because you have a lot of research, and then it becomes a very narrow funnel to making something into a product. And I don't have like a killer answer for that. Like, the best thing I've found for that to work out is knowing other parts of the industry and the company and understanding what. When I first did EyeToy, we had all these cool tech demos. And I went over to London and worked in a game studio for 3 months to transfer the technology. And it was really eye-opening to understand, like, from their point of view, they had to make a product that would ship. And I just had to make a demo that, just had to run in my office. So trying to realize how much more difficult their job was than I had thought was really a good thing. And it gave me a lot of respect for them and let the dialogue exist between them. So when it did go to get productized, we had a mutual respect, and then they could, ask me questions, and I could ask them things, and we could share more. Also, similarly with the business side, marketing and sales, and understanding what they would like to see happen, and understanding their point of view. So not just being an isolated researcher, I think, has helped me out a lot. But more than that, I think that more than any of this is I've played games all my life, and I care about games, and I would like to see games do certain things. And my kids play games, and I watch them play games. In order to be in our group, our R&D group, you have to play games. There's plenty of people who are very intelligent and are very capable that don't play games. We just don't need to have those people because there's lots of people who do play games. So we're lucky that it's a big industry, that we have a big pool to draw from. And having that knowledge and being able to have that dialogue with people about what we're trying to do is important. And so understanding the domain.
But for something that has never been in a game before, do you, they wouldn't necessarily ask you for that because they don't know it's possible for a camera to do that. So
Right.
you have to get to the point where an external developer is actually saying, yes, I'll commit to building a game around this, or I can make a game around this before you can.
Yeah, again, there's no magic bullet here. It's happened in different ways. With EyeToy, we showed it internally in the US, and they weren't really that's not what we were looking for. And then an executive in Europe said, we're going to make this. And then that's kind of the binary decision that happened because he was excited about it. In other cases, it has been more that they say, can you guys do this? And we say, actually, we can do that. So with PlayStation Move, somebody came and said, if only we had some kind of controller that lets you, move around and stuff. And we're like, well, we have all this, colored ball tracking that we've done for a long time, and we know how to do this pretty well. But we had never actually connected with the people that wanted that. So I think on the research side, there's kind of these three different modalities I've found that we've been in. Sometimes we're trying to push our research out to the company. It's really hard because product groups have their own schedules that they have to meet, and your thing was not on their roadmap, so they don't need you, basically. And you have to convince them. And so you have to just that takes a lot of energy and effort to push research out. There's other things where it's pull, where they say, can you do this? And it's, maybe just, those tend to be more incremental things, just making something they already knew how to do a little better. And we've done that too. And then there's the other case with like the colored ball tracking where we did it. Nobody was that interested. We set it on the shelf. A few years later, we had a need for it, and we pull it back out. And then, so remembering what you know how to do is also, we call it that stockpile mode or something where you build up a inventory of things that you can have the capability of and then be able to draw from that. So that's a long answer that doesn't really answer it. But
I'm Shane, and I was just wondering how Minecraft is with the Morpheus and the Move.
I have never tried Minecraft with it. We don't have that connected up. We've tried a lot of things with Move. We've tried like Half-Life. We tried that out. We had the Move mounted inside of a plastic gun, and doing that in Half-Life felt really great. And it was a very strong impression for a lot of people internally. We've tried with Move. We tried a lot of other kinds of game experiences. There's a product called, not product, but there's a thing called Move Me, which lets you run a program on a PS3, and it sends the data over a network of the move tracking, and then that can show up on a PC or whatever, and you can use the data. So you can basically, prototype things on a PC or connect them into anything you want, like any PC game that exists pretty easily. So we've tried Move with like StarCraft and weird things where, use it more for a.
So PlayStation can be relied on as a research tool.
PlayStation is not really probably a classic research tool. That was why we created that particular package, was so that people could try, because we felt this was a pretty unique input device, and it wasn't necessarily getting used in all the ways we thought it might on PS3. And so we thought some creativity from the PC community would be great to have, so we enabled that to happen. We can't always do that, but we did that in that case. And our model, we do have a lot more open model than we ever have for indie development right now, so it's a lot easier to become a PlayStation 4 developer, but it's not a complete open platform.
Mike, I have a quick question about in the Vive system,
Yeah.
they had something that I thought was brilliant, which was the chaperone, which would be sort of a holodeck style wall that would show up when you hit the boundaries.
Right.
And I don't know how much information you guys know about. I know you don't track the entire room, but you are tracking depth. So I don't know how much information you guys have, but are you planning on maybe a similar system so that people don't bang their Morpheus into the TV or something like that?
Well, I mean, compared to where the camera is, we know where the Morpheus is perfectly, right, in full 6 degree of freedom. We don't necessarily know all the furniture and other things that are in the room right now. For the Valve system, they have a very big area that you can walk around in, or at least that's how they demonstrated it. And I think that system worked really, really well, especially because like you're in a 5-meter area, and when you get about a half meter away from a wall, it warns you. So you can just kind of stay in the inner 4 meters and be pretty happy. When you have a little bit smaller space, like our system is, maybe 3 meters across at the widest where it tracks, and then it's like a frustrum, like out of a camera, right? So then you just don't necessarily want to give those little extra boundaries where it would warn you and stuff, because then it'll be popping up all the time, because you're in the edges a lot more often, I think. We don't have a solution. We've talked about different solutions for that, but our current content, you pretty much are seated or standing and leaning and stuff, but not walking around in your room. So it doesn't come up as often as you would. Now some people want to climb around and move around, and then they could potentially collide into things. I guess we could have a system that really warned you, but right now we haven't really finalized an answer to that. But I think that system worked really well. So the valve system.
You talked a lot about the different research you've done that's ended up in products, but what's some research you've done in the road you've gone down that just like ended horribly, or just like went somewhere you weren't expecting it to go? Or
Well, I did mention one of those. We did a lot of depth camera research we worked with PrimeSense very closely, and then Kinect came out. And the Kinect sold about the same number of units, I think, as Move, actually, maybe a little bit more. But it was perceived as selling a lot more, and it's perceived as being a much bigger success, partly because of marketing and things like that. But we really love that technology. We just didn't find that it resonated with the kinds of games our people wanted to make. And the biggest games that got made for Kinect, the most successful, are like dancing games. And it's just not something that our internal studios and Sony wanted to make games like that as much. They were more interested in more of like a VR kind of capability. Even though that was hard to make, that resonated more with what they thought would be good. And now, I think, as a company, we're very glad that we made this for what we're doing now, because it does fit in very well with what we like to make. But it was just not possible to make those things before. There's other things, there's lots of stuff we do at smaller projects. One of the reasons we have our group is we prototype stuff quickly, and like, this is going to be awesome. And then it's not awesome at all, and you're like, all right. Luckily, we only spent a week on that, right? So move on to the next thing. So that's also the kind of person we tend to like to have, is somebody who's not overly attached to, engineers often are like, they walk around the world with a solution, and they're looking for a problem that they can throw it at, right? And that isn't necessarily what we would like to do as a group. We tend to just want to keep trying to find problems and try out new solutions and throw away things that didn't work quickly. It's hard. You get attached to something when you work on it, and especially like the depth camera stuff. I worked on that for 2 years, and it's really hard to not. Yeah, and it's really hard to watch another company. But actually, I'm glad. See, now I have my Zen approach to it, where I'm very glad that it happened to the industry and that the industry gained this, right? But it wasn't so easy right when it happened.
I was curious my name's Eric, alumni from here from a long time back. I'm curious, what are the ingredients of a successful virtual reality entrepreneur in the business community in terms of academics and character and what you like to play with or whatever?
That's a good question. There are no like big mass market VR products out there quite yet, except even
Virtual Boy was
even the Samsung Gear VR is called an Innovators Edition right now, and it's got a limited installed base. Yeah, Samsung and Oculus. So I think we're finding that it's a very different set of things that people like to do in VR than necessarily they like to do in traditional console games. With a console game, a lot of times, they create these worlds, and then people just run through them as fast as they can to get to the other end or to do something. And in VR, at least right now, people are pretty happy just like seeing a world around them and maybe trying to play with it a little bit and do something in that world. We have this one demonstration made by our one of our physics people, and it's pretty easy with Morpheus just to kind of make a normal 3D experience into a VR experience, or at least to do it visually. And so he had this kind of cupboard and these objects, and you can open the cupboard with the PlayStation Move and grab objects and stick them in. And there's no like goal, but it's just like a sandbox kind of experience, and it's really pretty fun to just do that for a while. So I think I'm heavily biased here. I really think playing around and being able to cause something to change in the environment is really powerful. There are other kinds of experiences that work really well through something like a DualShock. Running through the world doesn't work great for a lot of people. They do feel nausea. But being in a vehicle and flying through the world and having the vehicle rendered around you tends not to make people sick nearly as much. So using a DualShock or something like that for a vehicle game, I think works really well. As far as characters go, we just started to see more of that happening. We have 2 demos we just showed recently. One is these cute little robots that you just saw, and they're in VR, and you can get really close to them. And people really like the fact that they kind of share the same space with those little robots. And then there's another one where it's the London Heist demo where you have the hands, but it's at the beginning you're sitting on a chair and there's this person kind of interrogating you, and he leans over you and he's very scary. And having him be in your personal space is a very different feeling. It is strong also, but not cute. So but on the business side, what is going to sell to a mass market? That is not an answered question, I would say. I'll go here.
On the Oculus, one of the things I have with the Oculus, because it's got the strap on and stuff, and it gets sweaty quick. And it drips. How's the Morpheus as far as the ability to keep it on for a while without worrying about sweat distortion?
I've worn it for a long, long time, like 8 hours before, during development of stuff. So it's a very different design than that. I find that, so the weight, it's called the halo design, and it sits on your head instead of pressing on your face, so all the weight is distributed. You'd have to try it, to know that. And then also it can move in and out away from your face, so you can kind of keep it further away from your face if you would prefer. And if you have glasses, also it can give you room for glasses. And there is kind of an air gap. It never touches the front of your face, really, so it lets air come in and through. It also lets a little bit of light through right now with this current design, so that's a little bit of a trade-off there. You could potentially modify it to let less light in, but then maybe it would less air in as well. So I think we are happy with the ergonomics that we have achieved so far. Things will always probably be focused on getting things lighter and stuff, but I think if you have a lot of hair, any kind of hat kind of feeling. It is open on the top, so a lot of the heat of your head goes out through the top. But I don't know. I don't want to answer that it's better, but we like this design. Yeah.
Just the fact that you can wear it for 8 hours.
Well, I wouldn't necessarily recommend that's the first day you'd start wearing it 8 hours. And when I was doing it, we were messing with a lot of VR parameters that probably most people would get really sick from doing that. But yeah. And also, it's kind of interesting that it is, well, one of the new things about the design is that you can just do this, and then you can kind of look out like this. So you can see the world just by doing that, and then still be. So you don't really have to change the adjustment very much. So they call it like the telescoping front thing. Go back there. Sorry.
So what's the SDK situation? Do you guys work with, do you partner with Unity, or do you have a Sony SDK for this? Or what's it like to be a developer for this?
Yeah, there's some great talks online, I think, by the way, if you want to. We just had a talk at the Game Developer Conference, and the first 20 minutes of the talk was about kind of that stuff, and the next 40 minutes was about 2 designers explaining their recent experience making a Morpheus thing. But Unity and Unreal are committed fully to supporting. They already have plugins for Morpheus. Also, this SDK supports the distortion and reprojection, so that you can get the latest update from the sensors and get your scene updated with that. It's pretty easy. It doesn't take very long to convert a thing. Now, making that feel like something you're happy with in VR, just making it show up is pretty easy, I guess. But then usually it turns out you have to change the design of your experience to make that feel good in VR. So we talk a lot. I talk a lot about the tech, and everyone's been talking about the tech of VR so much. And once the tech gets to a certain level, then I think it becomes a discussion about design, and we pretty much feel like that conversation needs to start happening a lot more right now. We think a baseline of tech has been achieved by multiple companies, actually. And we would really like to start having that more people focused on these great experiences and what people want to go out there and purchase and try out. Yeah. Here, I'll go first.
Yeah, it seems like there's a progression from hand tracking And you think about that being leg tracking being the next thing, and the concept of where locomotion is an issue. You wonder if people use their legs to move through the world. Has that been an experience, an observed experience, where the 5x5 meter experience, is there less motion sickness there? Because you think of like some sort of 3D flat treadmill where you can almost walk in any direction infinitely.
Yeah.
Is there any research in terms of getting the whole body involved, including the legs?
I think anytime you move the person and they're not really moving, you have this potential for some kind of feeling of sickness. And so like with the valve system where you walk all around, they try not to move you at all. It's only your own motion that ever moves you through the virtual world. And so that tends to make people the least sick, or not sick at all, according, they said they have 0% sickness from it, which I believe is probably true. The rest of the specs are pretty good too. So, and I've tried that system actually, and it is feels really great. We find similar things like, I guess, we tried out I had another intern before this who tried to use the accelerometers built in to measure footsteps like this, and so you could move through the world with footsteps. It felt kind of artificial, and I don't know, it feels like I'm doing a lot of work just to do something I could do a different way, and I don't know, it didn't make me feel more motivated to do that. I'm also not sure going more and more realistic is really where we need to be. Like, if I had superpowers, I would use my superpowers, right? So if I could teleport, I would teleport in the real world if I could do that. If I could, shoot fireballs out of my hand, I would be happy. But so trying to get as realistic as possible, maybe there's an avenue for that. I'm not sure we need to go as far as actually feeling like I'm completely walking. I've tried some other systems that are like a giant sphere and it rotates underneath you. That's interesting too. It never felt quite stable for me because the floor is a little bit sloped and it kind of moves out from underneath you. I think those are really hard and they're very big. All those kind of solutions are large, and I'm not sure they're fully necessary. They are fairly immersive, and you can have a fairly realistic feeling of like walking on a treadmill, but it's just maybe beyond what I could think is easy to do for a consumer product, so it hasn't been our area of focus. Go there.
Thanks. My name is Greg Rideau. I'm with Solid Art Labs, and it's a Chapel Hill early stage company. There's another company here called Wearality. You may know of. That's a VR company right here on East Franklin Street. And Wearality, their little device has the sides open, and the inventor of that device believes that as long as you let people get some sense of where they really are, they really will never get sick. And then I looked at Technical Illusions, which is probably the leading AR developer right now, and their mask has about 1/4 of an inch around the entire thing. And when I was wearing that, using my own controller, I had no sense of being ill at all. And I'm telling you, that was a phenomenal experience. We believe that you have to have tactile feedback, not only to avoid the sensation of being nauseous and motion sick and sort of loss of presence, of your own presence, that you have to have tactile feedback to play an interesting game. Your design is great, though. It looks like you've at least taken a step way forward from Oculus. I would give you that compliment, because you can actually kind of see out of it.
Yeah.
And get that motion sickness thing gone. What do you think about all that?
Well, we've asked a lot of people what they feel, and there's this really strong split we found. Like 50% of the people say, I want utter blackness. I don't get sick, and I want to be completely somewhere else. And the other half of people say, at least at this stage, I want to see my own feet when I look down, and I want to know the world is still there if I need it to be there for me. And I don't want to fully commit to being somewhere else that much. It's like,
Is that why you can pull it away?
yeah, so you can, that's part of it. I mean, you might want to take a sip of something, or you want to, look at your cell phone for a minute or something like that. Like, until we have.
So it wasn't to provide the visual stimulus.
It's for a variety of reasons. It's also to support glasses is a huge thing for us. And we're trying to find a compromise of letting the air through, not letting too much light through, but making people, so I don't know if this is the exact final balance we'll hit, but we're trying to find a good balance.
One last question.
Oh.
David Coleman. So you spoke a little bit about kind of social interaction. You spoke about the experience of having someone whispering in your ear, and obviously Facebook buying Oculus says that they care a lot about social interaction. How do you see social interaction going in VR, at least early on? On a mass scale, I guess.
I think, again, right now the emphasis has been so much on tech, and so we're all trying to make this ultimate virtual experience, and there has not been nearly so much stuff about the social side of VR yet. I think once the tech is kind of nailed down a little bit more and people are looking at the design and the experiences, once you feel what it feels like to have somebody else there with you, that's really, really compelling. But that only makes sense when there's a lot of them. So it's like this, first we need to sell enough that there's going to be multiple people that even could interface together. And then I think then it'll expand because they're interfacing together, and that's a very powerful thing. I don't know what exact experiences will happen, but just doing stuff together is kind of fun, and actually, there's really weird, like the demo I said where one guy has a crossbow, he can shoot something at your foot and you hear the arrow hit there and you look down. So he's like changing the world for you in a way that is pretty significant.
Where the kids on the playground stage.
Yeah. But just having somebody there with you, and also with their voice being there, it's actually more social than a normal multiplayer online game would be because they feel more like they're really there with you than otherwise. There's only one more question. Let's do that.
One last question.
Yeah, Sony and PlayStation is very much an entertainment system in many ways. And you all, I would imagine, have explored passive entertainment and filmmaking and the ramifications of using that device more in a passive way. Can you speak at all about some of those experiences and how it's sort of targeted in that way?
Sure. As I started, my focus is on the interactivity side, and that's what I care the most about. But as a company, there's many uses of a headset like this that are less focused on interactivity. And there's a lot of non-game things that you can do with a virtual reality system. And we're very much interested in that. Our focus as a company, our primary focus is games. But we do, on PlayStation 4, for example, you can watch, video streaming things and movies and things like that. And we think that's a huge part of enabling that. But it's just not the lead for us, right? So we have lots of companies coming to us wanting to do these non-game experiences, and we're interested in those, and we're making partnerships in that area. It was hard for some of those companies to do, not knowing when a product would launch. And now that we announced a launch window the first half of next year for our product, now those companies have a more concrete feeling of when they could start to fit it into their schedules for things.
From the depth cameras too, right? I think that was one of the interesting things is that the Connect and all that stuff. I think we discovered that people didn't want to jump up and down that much. They wanted to sit down and be entertained. And I'm curious if we're going to discover that about VR. This experience as well. There's going to be a certain amount of engagement that we're going to want to have. And part of us is going to want to be passive, and part of us is going to want to be interactive. And it's going to be a sweet spot. And I would imagine because it's a commercial, very commercial enterprise, there's got to be a sweet spot for a commercial product.
Yeah, there's definitely a big interest in Hollywood, for example, right now about how to tell stories in VR and what that means. There's a education that needs to occur because they think that you could just take a movie and turn it into VR, and that doesn't work perfectly that way. You don't necessarily have a full 3D environment that you could let somebody move around and look at. And then even the fact that they could be looking anywhere they want could ruin the whole storytelling experience. So there's some kind of cues that you can use. 3D audio is a great one for that because 3D audio doesn't have a limited field of view. So you can make a sound over here that will attract somebody's attention, make them look over there. I think that's a great way to help tell stories is through the audio. And so I think the passive experiences are valid. It's just not my particular area. I actually do interface with a lot of those companies because they're from other industries that I've dealt with in the past, so I know some of the people. But And like we're working with people like NASA and JPL on VR because they have a lot of expertise in that area. And we want to let them be able to make it feel like you're in space and you can look around you and see these great things. Those might be passive in some cases too. But yeah, I don't know. At this stage, our lead is on games. Whether games turn out to be the final biggest experience overall for VR, I don't know. But for a while, it'll be our biggest experience. Yep.
Okay, let's thank our speaker for one.
Thanks. And I apologize that not everyone can come and try this because it would take like 3 days for all of you to get to try this. But you can come and look at it if you want to just see the headset, and I'm happy to answer more questions too.
Thank you again. Thanks. That was great.